Let me introduce myself. My name is Rishi Bidarkar. I work for the performance team, and I'm co-presenting the talk, VMware View Performance and Best Practices, with my colleagues Sunil Sapnoor and Banit Agrawal. We seem to be having clicker issues the whole day. Let me put up the disclaimer slide up there. Please don't take the numbers out of context. Your mileage will vary. We all want it, and we all are working towards it, a good VDI solution. Let's see what it takes to have a good VDI solution. What's key for a good VDI solution, right? An efficient display protocol that works in any condition, any network condition, LAN, WAN, or extreme WAN. Yeah, sure. How about a highly scalable virtualization platform that will let you consolidate better or scale better? Yeah. How about that big red easy button where you can have a management stack which will let you scale and manage all your virtual machines seamlessly? Definitely. If you look at the VDI scope, we all know that there are more than just these three components involved. We all know that we need to understand each and every piece, how it fits into the whole end-to-end stack, and how it performs. And we need to keep track of the optimizations, the enhancements, and the best practices together. Let's look at some of these components, right? We have our storage optimizations. You have your hypervisor optimizations. Then vCenter gives you some enhancements, view enhancements, composer enhancements, and finally, last but not the least, client and protocol enhancements. When you look at these different components, the enhancements, the optimizations, to keep track, it can be a daunting task. Not to worry. What we have done in this talk is to simplify that for you guys. We will be taking all these components, highlighting the ones that are extremely useful and important, and coming up with best practices that you guys can see fit for your VDI deployment. So let me outline the agenda for you guys. I'll be taking you guys through some of the highlights that we have in the upcoming releases, like the platform and the view releases. Then we'll talk a little bit about some of the VDI benchmarking challenges that we faced and how we solved it with View Planner. Then Sunil will come up on the stage and talk about the platform enhancements and best practices. And then Banit will wrap it up with view enhancements and best practices. All right. You guys saw Steve's keynote today when he said things just have to work and they have to work well. That's exactly what has happened in 5.0. For VDI or latency-sensitive workloads, to have the maximum performance, we used to have some tunables in the previous release. What we have done, we have taken it, we have done some CPU enhancements by which, out of the box, you will be getting maximum performance. No tunables required. Everything will work seamlessly. Similar stuff has happened on the memory side as well. What we have done on the memory side as well is that we have taken a very dynamic approach in terms of memory allocation. Each VM, when it needs the memory, it gets the memory on demand. So what that does is it creates a bigger pool of memory for the other VMs who need it. And what that results in is better memory overcommitment as well as higher consolidation ratios. You will see that in following slides when Sunil and Banit present the numbers. Okay, these are the platform level improvements that have gone into 5.0. I want to talk a little bit about a cool new feature that we have introduced in 5.0. It's the 3D support. What we have done is we have used a software-based solution to start with, and we rendered the 3D graphics using your existing CPU cores. What is the benefit of this, right? You don't have to have expensive GPUs in your system or special client devices to access 3D. And that gives you out-of-the-box 3D experience. Some of the basic light 3D apps like Aero or Google Earth or Office 2010, which have some 3D built in, will work seamlessly. So this is something that is coming out and integrated very well with View 5. So take note and look forward for that. On the partner side, what we have also done with Teradici is there is introduction and integration of a PCIe server offload card. What this does is it is integrated with the PCIe infrastructure, and when there is image rendering in a VM, it knows who is using the most computationally intensive workloads, and it offloads it to this card. What it does is, because it's offloading, it's faster, so you have improved performance. And then because your core now has more cycles, you can consolidate better as well. So this is something that Teradici is offering. It's called the Apex card. There's a talk tomorrow at 1 o'clock. I recommend folks go to that talk. Okay, this is what we have done for the platform side, the vSphere side. Now, let's look at what is new with the VMware View, right? Where we take the view, it runs on this platform. There's a lot of excitement around some of the optimization that we have done in the protocol side. So I'll cover some of those at a high level, and then Banit and Sunil will show you guys the results and the detailed best practices of how you can avail these improvements. On the protocol side, we have improved on twofold, right? Bandwidth side and CPU side. So let's look at bandwidth improvements in WAN. In a typical VDI environment, folks, like a knowledge worker, opens different browsers, they read. There's a lot of text involved in terms of the workload itself. PDF browsing or Excel, everything has text. So what we did was we took a closer look at some of the algorithms and codecs that we use for text, and we have improved them so that you get a lossless text rendering, and we get bandwidth optimization on top of this. So we see that there's almost around 30% bandwidth improvement by just doing this improvement, moving to the lossless codec. Moving on, another change or improvement that was done was client-side caching. What I mean by client-side caching is when the images are rendered on the client side, it is kept in a cache, and when it is repeated, the server doesn't have to compress and send those bits over onto the network. It can just send a hash back to the client, and the client knows to render it locally. So that, again, gives us a big boost in terms of bandwidth. So that improves it another 30%. Finally, I want to spend a couple of minutes on this concept called build to lossless. PCIe, when it renders an image onto the client, it goes through 3 specific steps. First is it will render an initial image onto the client side. Then it will build up to perceptually lossless, and then if the client is still idle, it will keep building on top of that image till it is fully lossless. Now, fully lossless images are really good for a lot of different use cases, like healthcare. When a person is looking at MRIs, CAT scan, it is important. We don't want to get unknown diseases, do we? So it's extremely important that in that cases, lossless images are needed. But for a typical knowledge worker, we see that difference between perceptually lossless and lossless is negligible or indistinguishable. So in a typical workload, you might choose not to use build to lossless. And that, if you choose not to use build to lossless, we have seen up to 75% bandwidth improvements. This is huge in terms of how much bandwidth you can save. When Banit will come up and present the results, you'll see in detail how different network conditions we save how much. Now, we didn't stop at bandwidth optimizations, right? We took a deeper look at even CPU optimizations. In a typical VDI environment, as I said, you do a lot of reading, you take breaks. There is a lot of idleness built into the VDI environment itself. There is not much happening sometimes. So what we did was we made sure that all our components that are being used, like the PCIP server component, are using minimal amount of resources. We took a deeper look, we enhanced those, and now it is negligible. Why is this important? Because if one user is idle, that resource can be used, because it is shared on the host side, can be used by other users. So making sure that PCIP overheads are lower gives you that extra boost in consolidation as well. We also took a deeper look at some of our core functions, which were taking CPU, and we have gone and optimized it at a lower level so that we consume less CPU for these functions again. While we see so much of improvement in bandwidth, the compression schemes and libraries that are used, we made sure that they don't consume extra cycles. We diligently went back and looked at some of the CPU consumption that these libraries have, made sure that we use libraries which are highly CPU efficient so that we keep the bandwidth savings as well as optimize on CPU. So we have good bandwidth, better CPU utilization. What is also added in 5.0 is better session resiliency. If your network goes down, and if your session goes down up till 30 seconds, it will come back up and reconnect automatically. Your user will not even realize that it was down. So this is extremely useful for a lot of conditions, like in healthcare where doctors keep moving from room to room. It is useful for that in that use case. Another thing to keep track of is the performance counter that are being exposed by PCIP. These are per session counters that you can hook into the WMI-based framework that is exposed so that you can, at a high level, keep track of the health of all your users, not only on the client side, but on the network side as well. So you can keep track of how much average bandwidth it is using and what type of network it is using and stuff like that. So keeping track of these performance monitoring counters is extremely useful. If you guys are interested in deep dive of the PCIP protocol optimizations, my colleagues are giving a talk tomorrow at 1 p.m. I would encourage you guys to attend that session as well. Now, we also improvised the provisioning part of the product. There are optimizations so that operations inherently are faster. And we will also expose a couple of config parameters which you can use and make the provisioning go much faster in a parallel fashion. So stay tuned for that information as well. So these were the optimizations that went in the platform, the vSphere, as well as the view. Now, let's take a look at what are some of the challenges, right? How did we do this? How did we characterize these? How did we optimize? And how did we come up with the best practices? There are many components, as I said. You need tools that can help you characterize end-to-end. Let's take a look at what are the goals here, right? Very simple 3 goals. Capacity planning, which translates into consolidation ratio studies, right? You need to make sure that any tool or any characterization that you do has to scale well. Sure. While you're doing the consolidation and consolidation ratio studies, you need to make sure that you have a set standard for your users. User experience is extremely important. So making sure that you have a QoS that satisfies this experience is extremely useful or important as well. And keeping these two in mind, the studies and the user experience, you want to also optimize your entire end-to-end stack after you have made sure that these are there. So that's another, coming up with tunables for your environment is important. I'm glad to announce, guys, that VMware View Planner, which is a VDI workload generator, helps you with all these goals. If you're a partner or a customer, you can avail this product through VMware PSO. Let me talk a little bit about what is View Planner, right? As I said, it's an automated way of generating workload in VMs which scales to thousands of VMs. At the core, what it does is it's an Office user workload where you pick your Office applications. It will automatically open Word documents, modify the documents. It will open PowerPoint slides, go through the slides, and it will time all these operations and store it in a central place in a database. So you can then analyze the results. What can you do with these things, right? So let's look at some of the use cases. When we said capacity planning, okay, you have been given a task to come up with 5,000 user setup in VDI. What does it mean? How does it translate to how many servers do I need? What kind of storage array do I need? What kind of network links do I need? So using View Planner, you can size that. Second one was user experience. How do you evaluate user experience? Right? You have different network conditions. You have LAN, WAN, extreme WAN. What kind of experience your user is getting? Is it snappy enough? If I double-click on an icon, is it coming up in enough time? How do you know? How do you get that experience? What we have done, we have a unique patented watermarking technique that we have implemented in the product, which watermarks the display screen on the desktop, and it makes it over to the client side, and we tap into that notification. So essentially, when the user actually sees the window, when it sees the window pop up, that's exactly when the notification is rendered on the client side, and we get the information. So we time that accordingly. So if you have some users on WAN and some users on LAN, you appropriately get that information on the client side. So having a user experience metric is extremely useful. Now, when you do a scaled up run, what do? You have multiple VMs, you have multiple applications, multiple operations. All these operations are timed and stored into the database. But how do you make sense of these things, right? So what we did, we took a QoS methodology approach wherein we keep track of all these latencies, and for a typical run, we plot them in an ascending order, and we have a QoS methodology where the 95th percentile of these latencies have to lie below a threshold, like the T95. You see here in the chart, the 450 user run has passed the QoS threshold, but the 500 users has failed. Essentially, what we did was we took the latencies and grouped them. Why would you group the latencies? Because the latencies have specific characteristics, and you group them in different groups. And that's how the group policy or group QoS methodology is effective, and it has to lie below the threshold. This is a precursor. Folks have, so Sunil and Banit will come up and talk about the results. They'll be using this QoS methodology. Okay, View Planner, what are the features that are available in the current version, right? We ship as a virtual appliance, support 2003 and 7 Office versions. One thing I want to talk about was the custom app. Last year at VMworld here, we got feedback from folks like you guys that it's great that you have all these applications that you can run, but what about my app, right? What about a particular app that stresses the resources in a different way? I want to see that, right? What we did was we exposed the framework and let people write their own custom apps, and they can plug it into the View Planner framework and run these automatically, and we time them accordingly as the native apps itself. So that's something very unique and you can avail. A new version of View Planner is coming out. We are very excited about this. There is a lot of more support for our current and existing releases, security gateway support, multiple resolution support, all these new things. And we have also added tech preview support for ThinApp and Office 2010. So if you guys are interested in taking a look at the latest features for 2.x, we have a booth, PSO booth, which actually shows all these new features. So please stop by the booth and give it a shot. Okay, now we'll be talking about the platform enhancements and best practices. So I hand over the stage to Sunil.
Excellent overview of the VDI space and the problems that we are facing. So what I'm going to do now is focus on the platform optimizations and improvements that we have made in vSphere 5.0. So we have made CPU and memory consolidation improvements. As Rishi mentioned, we've made some CPU scheduler enhancements that will work out of the box and will give you better CPU consolidation. We have made memory footprint reduction. So that helps you pack more VMs on a given physical server. So the net effect of these improvements is summarized in this particular chart here. The blue bars are Windows 7 runs that we did on vSphere 4.1, and the red bars are what we did on vSphere 5.0. And we used the QoS methodology that Rishi was talking about. So basically, we ran the View Planner workload, and the latency should lie below 1.5 seconds for a run to pass. So you can see here that in vSphere 4.1, we had 11 Windows 7 VMs passing, 11 VMs per core, and the 12 VMs per core case was failed because the QoS latency was above 1.5 seconds. In vSphere 5.0, the red bars, you can see that we have been able to go up to 14.5 Windows 7 VMs per core. This is a very nice improvement, like roughly 30% improvement compared to vSphere 4.1. So we'll take a deeper look at what we did specifically and how we were able to get this consolidation ratio. So let's look at the CPU scheduler improvements we made. So we have in vSphere 5.0, the CPU scheduler runs better out of the box to support VDI workloads. If you remember, in vSphere 4.1, we had a best practice to set some scheduler parameters related to hyperthreading in order to get the best performance for VDI workloads. But we have not only fixed that parameter, we have not only made that as the default, but we have also done some other scheduler changes for hyper-threading that will give you better performance. So I have a chart here that explains the CPU utilization. So what we have measured here is the histogram of CPU utilization. So basically, we ran the view planner workload. It ran for like 5 or 6 hours. And we collected the CPU utilization every 1 minute. We sampled that. And we plotted that into a histogram. So what you can see here is that the CPU utilization increases as the number of VMs per core are increasing. So you can see at 13 VMs per core, many of the samples lie between 95 to 100%, but you also see some other samples that are between 80 to 85% and so on. And as you increase the number of VMs, the CPU utilization increases to a point where at 14.5 VMs per core, almost all the samples are between 95 to 100%. Now, this is the case that had passed the QoS metric. So we are making really efficient use of the CPU here. And for the case of the 15 VMs per core, the CPU utilization actually drops a little bit. You might think that it's a little counterintuitive, it should have gone up further. But the moment you have more than the required number of VMs on a given physical setup, you run into swapping and ballooning and all these issues. And that will actually reduce the CPU utilization. So as you can see here, we are making full and efficient use of the CPU and still passing the QoS. Now let's look at the memory improvements in 5.0. So in addition to the VRAM that is allocated for desktops, the hypervisor also has to keep track of some bookkeeping memory, like on behalf of that VM. We have significantly reduced this bookkeeping memory in ESX 5.0. So as you can see here, we have normalized the memory utilization, the bookkeeping memory in ESX 4.1 and 5.0. And for a 1 gigabyte VM, the reduction was 60%. Now, this is a significant savings with respect to bookkeeping memory. What this means to end users like you is that you will be able to run more VMs on a given physical host because we are freeing up more memory. So we have some example scenarios here. Now, let's assume you have 1 gigabyte VMs. You're not doing any overcommit of memory, and we'll ignore some of the other the memory that the hypervisor needs to run. So what we're seeing here is that if you have a physical server with 96 GB of RAM, on 4.1, you were able to run 84 VMs. But in 5.0, you're now able to run 91. Similarly, as you have more and more RAM on a given physical server, you're able to run more VMs. So for example, in the 512 GB server case, you're able to run nearly 40 more VMs on the same server. Now, is this all you can run on a given physical server? Definitely not. You can do more than this. And the reason for that is we have further savings in memory because of other technologies that we have. We have transparent page sharing, we have ballooning, we have memory compression, we have swapping, we have a whole bunch of other technologies that you can use to further improve the consolidation. So let's take a look at what I'm talking about. So this graph shows you the amount of memory you can save by transparent page sharing. Now on the y-axis, you can see the amount of memory that you were able to save when you are packing so many VMs on a given host. Now at 21% memory overcommit, you are able to save approximately 40 gigabytes of memory. That's a huge savings. And as you increase the number of VMs on a physical server, the amount of page sharing that you can do slightly reduces. Because when you have a lot of VMs on a given server, it will cause ballooning, and those pages will be swapped out to the disk, and they cannot be shared anymore. So up to a particular point, we'll be able to do very good savings of memory by page sharing. And as I said, beyond a certain point, ballooning will start to kick in. So what happens when you're packing a lot of VMs onto a physical host? So the balloon driver within the guest starts to inflate, and it causes the guest memory to be swapped out to its page file. So you can see that at 21% overcommit, the peak ballooning was about 2 gigabytes, but the average ballooning is still very low. But when you go beyond 20%, like 25% overcommit, you see that the ballooning increases. Now, ballooning is good up to a certain extent because it can save memory, it can it enables you to run more VMs on a physical server. But that doesn't mean it's good beyond a certain point, because once you start swapping out the actual working set of the VM, then you'll start running into performance issues. So you can run a lot of VMs on a given host by overcommitting on the memory. Like our experience has shown that you can go up to 20% overcommit and still get reasonably good performance. And in ESX 5.0, we made another improvement with respect to ballooning, where we follow a more conservative approach to ballooning. In 4.1, we were actually aggressively ballooning out the memory, and that would result in poor performance at an earlier level. But in ESX 5.0, we are taking a conservative approach which delays the memory till the last possible moment until it is absolutely needed. So this further gives you memory consolidation. So to summarize this, how far we have come in 1 year. So last year, we were talking about Windows XP VMs and vSphere 4.1. And when we ran the View Planner workload and measured how many VMs you could pack on a given server, we were seeing that you could do about 13 VMs per core, 13 Windows XP VMs with 1 GB VRAM on a 96 GB physical server host. So this was last year. Now this year, again to show the same graph, we are now able to run 14.5 Windows 7 VMs on the same machine. Now what this means is you can not only run the same number of VMs that you are running, but you can add more number of VMs. We've made significant improvements, and we all know that Windows 7 has more memory footprint than Windows XP. But in spite of that, we were able to drive more number of Windows 7 VMs because of all the memory improvements that we talked about. So I hope you guys are happy with these results, and you will be able to see more consolidation in your actual deployments. So let's come to storage. And a lot of people are implementing storage tiering. So if you look at a desktop VM, it has many virtual disks. It has the OS disk, the C drive, and then it has the persona disk where the user stores his data, and then you have the disposable disk which has the page file. So not all of these disks need to go to the same data store. So if you look at the I/O distribution in a VDI deployment, you'll see this 90-10 distribution. So what I mean by 90-10 is that there are periods of extreme IOPS requirements when there is boot storm and recompose and all these operations. And then there are periods where the I/O requirements are low, when your desktops are running a steady state workload like Office applications. If you look at the breakup of the IOPS, then you see that during the boot storm or the recompose, there are a lot of IOPS going to the replica disk or where the OS disk is stored. So that's the reason we can store it on an SSD data store so that you can get the maximum IOPS. And during the steady state, 90% of the IOPS are going to the other virtual disks. So what this means is that while the desktops are booting, there are 90% of the load that is directed to the SSD data store, and during the steady state, 90% of the IOPS is directed to the non-SSD data store. So you can maximize the SSD data store usage by running other workloads on it. Like, for example, you can run file servers. So after the desktops have booted, the SSD data store hardly has any traffic on it. So you can run a file server and maximize the usage of those SSD data stores. So to summarize the best practices that we've talked about till now, so for CPU, we were able to run 14.5 Windows 7 desktops per core for light to moderate Office applications. Your mileage may vary because you might have different applications, you might have different kinds of workloads, like you might have developer workloads or you might have aggressive user workloads. So for that, you can use the View Planner tool with the custom application support to actually run your application at scale and find out how many desktops you can run on your physical server. With respect to memory, we were able to do significant memory savings in ESX 5.0. like 8 to 15% more. So you can pack more Windows 7 VMs onto the same server now. And on top of that, you can avail of all the memory saving techniques that we have to further overcommit on memory. So with respect to storage, you can use SSD data stores to store the replica disks to avail of the high IOPS load during bootstorm and recompose. So that was the platform improvements. Now I'll briefly talk about some of the View Composer improvements that we've made. So one thing that customers have asked us is, it takes a lot of time to provision so many desktops. Like I have 1,000 desktops. It takes about an hour or 2 hours to deploy or provision all these desktops. So is there any way to speeden this process up? So you can do that by increasing the concurrency of these operations. So by default, we let the View Manager and the vSphere, the vCenter server, only issue so many provisioning operations. We do this because we assume that a majority of the customers have a particular set of storage. Now, if you have a faster storage, you can obviously bump up these concurrency limits and get better performance. So what we've measured is we have compared View 4.5 with View 5.0 out of the box. And then for View 5.0, we also set a couple of concurrency parameters. We were able to bump that up and get better performance, as you can see here. So these are the parameters that you can set in the Atom server to bump up the concurrency parameters so that your provisioning times, your recompose times are significantly faster. So with that, I come to the end of my section about the platform and the View Composer. So now Banit will take you through the protocol and the client-side improvements and best practices.
Thanks, Sunil, for giving the detailed performance results on the platform side. Now I'm going to walk you through to the performance of protocols improvements that we have done with PC over IP in the upcoming View 5.0 release. So before that, let me give you a glimpse of the experimental setup. So we have used IBM Blade, 2.53 gigahertz Harper-Town, and the box has 32 gig RAM. It's connected to NFS storage array. Here, vSphere 4.1 is used for View 4.5, where we are comparing with View 4.5. vSphere 5.0 is used for View 5.0. The desktop VM we have used is 32-bit Windows 7 desktop VM with 1 vCPU, 1 gig RAM, and 1152 by 864 resolution. And the workload, as Rishi pointed out earlier, that we are running View Planner with all applications and 20-second think time. And the client, again, we are using PC over IP protocol with build to lossless off. As Rishi pointed out earlier, that we don't see much difference in the quality if you're using Office workload, like if you're doing build to perceptually lossless or if you're doing build to fully lossless. For all practical purposes, you won't differentiate the image quality. And here we are comparing against with 3 network conditions. So LAN, as you typically use, and WAN and extreme WAN. So we will show that in extreme WAN, how we have improved PC over IP and how much we have improved the bandwidth usage for the extreme WAN conditions. So what are the metrics we all care about? So we want to maximize the user experience, right? So that all VDI users are happy. We also at the same time want to minimize the resource consumption, right? So that we can save cost. So what does this translate to different performance metrics? This translates to that we minimize the response time of applications, we minimize the bandwidth usage, and we minimize the CPU usage so that we can have better host consolidation. We can support more number of users on the same network link, and as well as we still get out the best user experience from our VDI deployment, right? So these are the metrics we'll be focusing on for the rest of the results that I'll be presenting. So here is the results which is comparing View 4.5 and 5.0, the user response time. So on the left, you see the legend for the performance metrics that we are talking about. And on the right, you see the chart. The purple color here is View 4.5, and the blue color is for View 5.0. And on the y-axis, you see the normalized response time. In this case, in View 4.5, in extreme WAN condition, we see the maximum response time. So in this case, we are using this as baseline. It's normalized with 1.0, and everything is scaled with respect to that. On the x-axis, you see different LAN, WAN, and extreme WAN conditions. So as you see that as we go from LAN to extreme WAN, the application response time is increasing. But in LAN and WAN, if you see, there is not much significant difference in the application response time. But if you look at extreme WAN, we are seeing about 15% better user experience or better lower response time in View 5.0. So this is more noticeable in extreme WAN condition. Now let's look at the bandwidth usage. So why did we see that in extreme WAN in View 5.0? This is precisely the chart which is talking about it. Because here on the y-axis we have shown normalized bandwidth usage, and we have seen 75% bandwidth usage with typical view planner workload. On LAN we are seeing 75, on WAN and extreme WAN we are seeing about 70 to 75% bandwidth improvement. So what does this mean to you as a VDI deployment or as an IT administrator? On the same link that you were supporting, now you can support 4 times more users. So for example, if in your link you were supporting 10 users, now you can support 40 users on the same link. Another thing I want to point out here is that in View 5.0, almost all network conditions, like for a typical office user workload, we are consuming less than 50 kbps bandwidth, which is quite less considering a typical office user workload. Now that I have presented you the user experience and the bandwidth usage, now let's look at the guest CPU usage. So here in the LAN condition, we are seeing about 10% bandwidth CPU improvement, and in WAN and extreme WAN, we are seeing about 5 to 10% improvement. Please note that while we have added some new features like lossless codec and as well as client-side caching, we have still, because of all the improvements that we have added, all the code optimization that we have added, all the new optimized libraries that we have added, we are seeing better CPU usage. So what does this mean is that now you can have better host consolidation for your VDI deployment. So now I'm going to switch gears and now give you a results comparing different display protocols. So for different display protocols, these are the settings we have used. So for PC over IP, we have used View 5.0 internal build with progressive build set to BTL off, which means that it will build to perceptually lossless quality. For port ICA, we have used Citrix Gen Desktop 5.0, and again we have used progressive build with default settings. For RDP, we have RDP version 7, and network setting is set as per the network condition we are doing. So now let's look at the results here. So this chart is showing the application response time normalized. The blue color is for PC over IP, the red is for port ICA or HDX, green is here for RDP 7. And again, we see 3 network conditions, LAN, WAN, and extreme WAN. And in this case, RDP in the extreme WAN has the highest response time or the lower user experience. So that is normalized to 1, and everything is scaled with respect to that. So now if you notice, in LAN condition, we don't see much difference in terms of the user experience. As we move to WAN and extreme WAN, we see that PC over IP provides a better user experience and lower response time with respect to HDX and RDP 7. Now let's look at the bandwidth usage. On the y-axis, we have normalized bandwidth usage. In this case, RDP is consuming the highest maximum bandwidth in LAN condition. So that is normalized with 1, and everything is scaled with respect to that. So in this case, we see that PCOIP is providing 60% better bandwidth usage compared to RDP 7. As we go to WAN and extreme WAN, we see that the bandwidth usage has gone down slightly, and PCOIP still providing better or at par bandwidth usage compared to the other protocols. Another thing I would like to point out here is that even though like if you see that the bandwidth usage in RDP7 has gone down, the reason behind is that in RDP7, like for example, the video and the web Babylon, which are highly graphics intensive application, RDP7 is more, it cripples and it's less usable. So that's one of the reason we have seen the bandwidth usage going down. It could have been even higher. Another thing, so now let's look at the CPU usage. So here, port ICA or HDX consume the highest CPU usage. So here on the LAN condition, it is set to 1.0, and then everything is scaled with respect to that. Again, here we see that PC over IP, even though we have added a lot of these new features, and because of all the optimization that we have added, we are showing less CPU usage compared to HDX. And we are also showing better performance in almost all network conditions. And again, as I pointed out earlier, that RDP7 is less usable in the extreme WAN condition. So it's kind of difficult to compare against. So now that I have presented the comparison of protocols as well as the prior View 4.5 release, we have also added some new features. So now we have added some perfmon counters. So there is 30 plus different performance counters that you can actually look into WMI based tools or in perfmon. So you can do the better monitoring of your bandwidth statistics, audio statistics. So there are different statistics that we have added. So you can use it for performance monitoring and some troubleshooting for your user session. So now let's look at some of the best practices that you can do and what tunables that you have at your hand to tune further. So the first thing I would like to point out is the client-side caching. It's on by default, so I would recommend just leave it as default. Another setting now, next one is the build to lossless. It's enabled on by default, so it will build to fully lossless. So for example, let's say if your users are just running Office apps. So for all practical purpose, you won't see, because you won't see any difference with respect to fully lossless and perceptually lossless quality, you may want to disable this setting. This will save you up to 30% bandwidth usage on your network link. The next setting here is session audio bandwidth limit. So here the default set is, the consumption is 500 kbps. Again, you can set this to 50 to 100 kbps. You will still get usable audio quality, and this will save you a lot of bandwidth. So the first three, you can set it as default for your environment. The next two, you may want to set it as for your network conditions. So the next one is maximum frame rate. The default is set to 30, but if you have, let's say, you on a 2 Mbps network connection or maybe 1 Mbps, you may want to set it to from anywhere between 10 to 15. So you will still get good video playback, and also you will get like high graphics intensive. So it will help that, and it will save you a lot of bandwidth. The last parameter here I'm going to talk about is the maximum link rate. This parameter, again, you set it as for your network conditions. This is good for better bandwidth estimation, and this will also reduce interference across many users sharing the same link. So you may want to set it as for your network environment. So now that we have looked into PCU-IP tunables, now let's look at what are the tunings you need to do at the guest level. So again, vCPU memory, this is the same experimental setup that I talked about we have used for our analysis. So one vCPU for XP, Windows 7, but if you are using multimedia or highly CPU-intensive apps, maybe you want to give 2 vCPU. Memory, again, 512 to 768 meg for Windows XP, 1 gig for 32-bit Win7, and 2 gig for 64-bit. A network adapter, we have seen better performance with VMX-Net 3, so you may want to set that. Storage adapter, again, PV-SCSI or LSI logic, SAS you can use. And please make sure that you have latest VMware tools installed in your VM. And another thing I would like to point out is the visual settings here. So if you want to save good bandwidth and you are on a WAN condition, you may want to set your window visual setting to adjust for best performance. And then you can also disable some services. So why this services disabling is important is because when you have link clones, because of all the services, all this happening, what will happen is your redo log growth will increase. So either you periodically refresh and then have the new updates in the master VM, you can do that. But we would recommend that you can look into these settings, see what it fits for your environment, and then you can save a lot of redo log growth that happens with your link clones. Some more settings on the group policy. So disable hibernation. You can set screensaver and wallpaper to none, so that will save you some of the bandwidth. Now that we have caching in place, maybe you can set wallpaper because that caching will take care of it. Then you can also disable system restore. And some of the other settings that I want to talk about is clear type fonts. So we have seen that if you turn off clear type fonts, it can save you anywhere between 10 to 15% bandwidth savings. And if you want to also disable, you can disable fading effects for your WAN environment. So more details on all this optimization on the guest, PCOIP, and this one is coming in a white paper. It will be on the vmware.com. So you can check it out. So now let's move on and look at the bigger picture. So we look at the client-side performance monitoring. So we have now new perfmon WMI counters that you can use to troubleshoot PCOIP session. And you have a lot of PCOIP tunables that you can adjust for your WAN environment. Now let's look at the edge router in your big network diagram here. So what we have seen is that if you have deep UDP packet buffer, the latency is going to increase. And since PCOIP is an adaptive protocol, it may scale down the bandwidth slightly. So you may want to check the UDP buffers that you have in your edge router. And you also make sure that you have better queuing algorithm in place, better traffic priority is assigned for PCOIP traffic. So all this optimization or settings that you can check in your edge router for better user experience. And if you are using VPN, we have seen that VPN over UDP or in the DTLS mode seems to provide better user experience. And we have partners like Cisco, F5, Juniper have several white papers that talks about how you can use VPN with UDP. And if you are not using UDP and you want secure connection to your desktops, we have PCOIP security gateway that you can use, and that started providing that gateway a solution in View 4.6. Another thing I want to talk about here is that the WAN accelerator. So again, we have provided mechanism so that the PCOIP traffic can be decrypted and then it can be deduplicated at this level, and then you can have a functionality of WAN accelerator. So there are many vendors, well-known vendors working on it. So stay tuned for that. It's coming soon. So that brings me to the conclusion slide here. So as we have seen that because of all the CPU and bandwidth improvements, View 5.0 is quite providing much better performance improvement compared to the View 4.5. So we are seeing about 75% bandwidth reduction in almost all network conditions. We are seeing improved consolidation ratio because of both View 5.0 improvements as well as ESX5, vSphere 5.0 platform improvements. And on top of that, we have added new features in View 5.0 like 3D graphics. We have more observability because now we have PCOIP session counters. And now we have session resilience, and we have also what Rishi talked about earlier is the Teradici offload cards that you can use. So View 5.0 provides better user experience, so all the VDI users are happy, and it can save you more costs, so IT administrators are happy. So that means that everyone would be happy. And on that happy note, I would thanks everyone for attending this talk. Don't forget to fill out the survey session, and I would open up the stage for questions. Thank you.